Good morning, Chloe. Sorry I didn't get to your questions last night. It was quite the hectic trip from Dallas to Las Vegas. I'm sitting in my room right now, which is ridiculously green. Um, but when I fell asleep last night, I was like, oh no, I didn't get to Chloe. So I am making this video right now. It is 8:36 a.m. your time. It's actually 6:36 Vegas time, but my body is still on Central Time. So I've been awake for a while, and I figured this is a great thing to do to get me started to help you out before I begin an adventurous day in Las Vegas. Okay, so I'm looking at your images that you showed me, and we're going to actually look at the questions specifically in your homework. And I was looking at this homework and I noticed that you had done, oh, by the way, this video is unlisted, so nobody can see this except me, you, and anybody that we decide to share this link with. I'm not going to share it with anybody. If you want to, you're welcome to. But I noticed that you did pretty good on this homework, and the only ones you're struggling with are the ones that you asked me about, which makes perfect sense. So we're going to take a look at the ones that you were struggling with that you didn't answer. And I think each of these has a little thing that once you see it, you're like, oh, that's all you wanted me to do. So we're going to start with question 8, part B. They ask you to find f of 57. Now you found f of -7 was equal to 7, and I'm assuming that that's because you just plugged the number in and you worked it out. So I imagine that when you plugged in 57, it may not have worked out cleanly, except now that I look at it, it does. So I'm not quite sure why you would have gotten part A, but not part B. We'll take a look at it real quick. And then part C is really the part that some people aren't quite sure what to do with. Let me open up a screen here. Okay. And oh, I didn't grab my stylus. Hold on. I got it right here. Okay. So let's, and I hope the stylus is decent. Let's look at question 8, part B. And they ask you to find f of 57. Now, our original function was f of x equals the square root of x plus 7. And I think there was a plus 7 out here also. This is not my best stylus. Sometimes the lines jump a little bit. Let me make sure that was the question real quick. Yes. Well, it said f of r, but you know, the name of the variable is totally irrelevant in your function. Whether you call it f of r or f of x or f of w or f of t, it really doesn't matter. All that matters is that whatever's inside the parentheses here, you're told to do something to it over here. So whether it's r, x, it doesn't really matter. This function says, give me a number. I'm going to do the following to it. I'm going to take it. I'm going to add 7 to it. I'm going to put all that under a square root, and then I'm going to add 7 to that. Now, I'm not sure if you just froze up on this one because the number was larger, or you caught a glimpse of the next one, which had a letter in it. But this one actually plays out pretty straightforward because when you add 57 and 7, you get 64. But that's still under a square root. And the square root of 64 is just 8. So upon seeing the conclusion of this, you're probably scratching your head saying, well, why couldn't I do that? And the answer is, well, you could have. There might have just been some mental block that prevented you from going through that problem pretty straightforward. I think the part of this that might make you struggle a little bit is the second part. And the second part was to find f of x. Excuse me, let's put that back the way it was. The second part was to find f of x minus 7. Now, I understand for some people, maybe for you, maybe not for you, I understand for some people, the intimidation factor when you bump up the problem from something like f of a number to f of an expression. But there's a very straightforward way to approach a function problem like this where the thing on the inside, I'm about to highlight it here, is more than just a number. The trick is to take this guy here, bring him down. So we're going to bring that down. And I'm going to write it exactly like it is for now, but it's about to undergo a change. And there's a reason why I wrote that square root really wide and the plus 7 far away from the r. Because when you do a function problem, you take whatever is inside the function, whatever letter is inside your function, which in this case is this r here, and you're going to remove it and you're going to replace it with what was inside the parentheses. So I'm going to erase this r, And in its place, I'm going to grab this and put it right there. Now, sometimes when you put an expression into another expression, like the x minus 7 in the place of the r inside of the square root of r plus 7, sometimes it's necessary to put parentheses around what you put in, depending upon where you put it and how it's attached to the things around it. It's never wrong to put the parentheses. Sometimes it's wrong to not put them. In this case, because I put it inside of an addition problem, it's actually okay to not put the parentheses. I'll take that back to black. So I'm just going to drop those parentheses. Namely, there's nothing being multiplied into the thing that I just put in, nothing being multiplied into the yellow thing, so I don't need the parentheses to fix the order of operations. Let's see. Well, what happens here? Well, this is actually pretty easy now. The 7's cancel. We're left with the square root of x plus 7. And if you're not sure where to stop, then you ask yourself, well, is there anything left to do? Well, no. I don't know what x is, so I can't square root it, so I can't very well follow up with what the square root of x plus 7 is. So this would actually be your final answer. You've created a new function by substituting the original variable r with a different expression, x minus 7. All right, let's go to the next question that you had, which I believe is question 10. All right, so question 10. Question 10. Why is it not going to question 10? Okay, graph the given functions, and it looks like you actually put some graphs over here. Let me glance at them real quick. I want to say your first one, hold on, over 1 up 3, over 1 up 3, over 1 up 3. Okay, I can tell that your first one, the one that goes to the origin, let's zoom in on it. I can tell that this one is not the correct graph. I can't, it doesn't tell me, actually it does. You put a dot up here and you put a dot down there. This dot is over 5 up 15, I believe. Except it's over 6 up 15. I think when you were plotting this first one, yeah, that's what happened. You it looks like you put the origin, which was 0, 0, and then I think you were trying to put the point 5, 15, which is what you would get if you put 5 into this function. 3 times 5 is 15. But looking at it more closely and following its vertical line downward, it's actually 6, 15. So I think on this one, you might have just accidentally clicked the wrong line, clicked the wrong dot. And for the second one, the second one, you did exactly what you were supposed to do. The 2 dots that you clicked are 2 lower than the 2 dots that you originally clicked, and that was because of the -2, most likely. So I think this one, you just made a mistake when you were clicking the second dot so far away. What I would recommend, and it won't let me actually do it here because I'm reviewing your work and not actually doing. But what I would recommend for a problem like this that you know is a line for whatever reason, either you drew it in advance or you already know that these are in slope-intercept form, which is something that happens in section 2.3. But if you knew it was a line, then you can get away with just graphing 2 dots, but I wouldn't pick 2 dots that are so far away. For example, if I were doing f of x equals 3x, let's go back to the board here for number 10. If I were doing f of x equals 3x and I knew it was a line, and for all I know, you may remember from days gone by that this is a line, its slope is 3, its y-intercept is 1. Or you might have just graphed enough dots before you found out that it was a line. But if you knew it was a line and you only needed 2 dots, I would put in 0, triple it to get 0. I'd put in 1, triple it to get 3. I'm about to sneeze, excuse me. I'm so sorry. And you could put in more dots, but the advantage to putting in 0 and 1 is that the 2 dots aren't that far from each other. And when you connect them online, it'll instantly draw the graph. I think you put in 5 and got out 15, but when you went to click 5, 15, you accidentally moved over to 6, 15, and hence the graph got thrown out of whack. But the problem with 5, 15 is that when you go up 15, it is very easy to accidentally move left or right just a little bit and misplace that dot. So I think that'll fix the question or the problem you were having with number 10. I'm going to pause this for a second so I could go blow my nose. Oh, goodness. My nose is running off my face. Hold on 1 second. All right, much better. Okay, so I think that's going to fix question 10. If not, you can just text me. And I believe you also had a question on 11, 12, and 13. So let's take a look at 11. 11 is going to run the same way. So if I'm correct about the mistake that you made on number 10, which obviously would have discouraged you from doing number 11, then number 11 should be pretty straightforward. Let me see if it'll let me graph. It will. For example, this is the easiest function ever. It's actually called the identity function. Excuse me, the identity function. F of x equals x. For a couple of reasons. Number one, it preserves the identity of the number you give it. Give me a number. Now I'll give it right back to you. Put in 5, I get out 5. Put in 10, I get out 10. Put in 0, I get out 0. So that's a pretty easy one to graph. It's a line. I could go to the origin. I could go to 1, 1, and boom, there's a line. And for the second one, the +4, just move everything up 4. So if I draw another line and just move it up 4, and then the other one up 4, there you go. Later on, there's a section 2.4 where you talk about these lines and the fact that they have the same slope and it makes them parallel. If you know what all that is, great. If not, you will eventually. It's not that difficult. So I'm betting that the only reason you froze up on 11 is because 10 wasn't going too well and you couldn't figure out why. But if my instincts are correct, the only reason you missed 10 is because you accidentally misclicked the second point. Question 12. All right, now this one's not going to be a line because of the x squared. And I'm wondering if 12 and 13 were skipped because of 10 being an issue. Let me see what 14 is. Yeah, 14, the problem changed, so you were okay. So I'm thinking that you probably just got a little bit frozen on 10, couldn't figure out why it was wrong, and then just go, well, this is the same question, the same question, this is the same question. Now, these last two, 12 and 13, are a little bit different because the functions aren't just lines. I can tell because this has a square and this has an absolute value on it. So I'm going to demonstrate one of these. I'll demonstrate both of them for you. Number 12, f of x equals x squared and x squared plus 3. What you probably know by now is that whatever the first one does, the second one's going to move it up 3. And on 13, whatever the first one does, the second one's going to move it up 8. So it really boils down to what does the first graph look like. Let's take a look at the graph of number 12 real quick. I believe I have a video about this being one of the basic functions. I can't remember. I think it shows up later than this video. In this video for or videos for 2.1, you're just learning the basics of functions, not really looking at specific functions. At least I don't think so. Let me go back into Canvas and look at the modules for that. I've recorded these videos over 2 years ago, so I don't quite remember exactly who, and I'll switch over so you can see what I'm looking at. Don't exactly remember which videos cover which specific topics. So in 2.1, no, I know what I'm thinking about, and I think it happens here in 2.5. Yeah, in 2.5, they talk about some graphs of common functions, including f of x equals x squared and f of x equals the absolute value of x. But earlier in section 2.1, where you don't have this information yet, which you may or may already know, it's an issue of how do you get the graph of a function when all you have is the function itself, like f of x equals x squared. So we're going to make the graph of f of x equals x squared. Actually, to save me a little bit of time and to save you a little bit of time, let me try something real quick. What I'm going to recommend for you to do to get a jump start on questions, to get some help with questions 12 and 13, is to jump ahead to 2.5. And I think in 2.5.1, I'm not going to play all of it. Actually, I can tell here, yes. Notice that over here, it has the absolute value function. So if you just want to jump ahead to see what it looks like, go to this video, Let's close all this and skip ahead until you get to the absolute value function, which is right. Well, obviously the auto thing didn't know when to jump from identity to absolute value. I'm looking at that little screen down there to see when it jumps to the third column. Looks like about here. Let's play it real quick. Okay, yeah, over here it starts talking about the absolute value function. And you can see it right there. It's a V shape. So surprise. And then if you go to the next video, I believe it talks about x squared. Yeah, there it is. X squared equals this. So if you want to get the details about those two graphs, the graph of, let's see, trying to get it to share something else. The graph of f of x equals x squared for number 12 and f of x equals the absolute value x for number 13. I'm going to recommend that you go watch, go ahead of in the modules. Go to module 2.5, watch 2.5.1 and 2.5.2, or at least the parts that you need to help you with this question if you don't want to just figure out how to graph them on your own. I'm going to write down what I just said, and I'll type it here. For question 12, watch the beginning of video 2.5.2 in module 2.5 for question 12. And for question 13, watch the end of the video of video 2.5.1. All right. So hopefully this will help you with the questions that you didn't answer yet on 2.1. I'm encouraged by the progress that you already made. And I'm glad you're trying to get caught up. I know life happens, but because you got that extra 2 weeks, hopefully you can get it done. I say hopefully because next week is the quote unquote last week of the class. So technically you have 3 weeks to wrap things up. If you got any questions or if you're not sure what I meant by all of this rambling, just send me a text and we'll get it figured out.